keep students in mind. Now we are getting closer to the end of the year. I know you're sad about that. We're going to take a step back from calculating specific statistics and talk about statistics more in general and different sampling methods. So if you want to pull up the blank note sheet I posted, you're welcome to go through and fill this out with me. So first things first is the vocabulary around statistics. We kind of talked about population and how there's two different kinds of standard deviations, a population and a sample standard deviation. So I'm going to reiterate, a population is when an entire group of people or objects that you want information about is included. That's why a lot of times with standard deviation, we use the sample because it's extremely hard to get every single junior in a high school or every single 40-year-old in this country, okay? But if we can actually manage to do that, then the statistic we gather is the numerical characteristic for the population is what we call a parameter. Now, parameters aren't very common because, like I said, they only come from populations, and populations can be really hard to get. So a parameter is kind of a population's version of a statistic. Okay, because it's so hard to get population, like a whole population, a lot of times what we do instead are samples. And one kind of sample that we aim and strive for as much as we can is what we call a random sample. And that's when each member of a population has an equal chance of being selected as a representative subset of that population. Okay, we want it to be random because we don't want a skewed view in what we gather. So when we gather stuff, that is now what we call a statistic. Okay, a statistic is a fact or a piece of data from a sample. So remember, parameters come from populations, PP, and statistics come from samples, SS. So easy to remember, huh? Okay, so just using our vocabulary in broader senses. You collect data about a population by surveying some or all of the individuals in the population. Okay, when all individuals in a population are surveyed or studied, the data gathering technique is called a census. We were just trying to do a 2020 census so we could gather information about the entire population as a goal. Okay, a parameter then is a number that summarizes the characteristic of the population. When only some of the individuals in a population are surveyed or studied, the data gathering technique is called a sample. A statistic, remember SS, is a number that summarizes a characteristic of a sample. Statistics can be used to estimate parameters. Okay? When data collected is a numerical value, height, income, etc., it's called numerical. When data collected is not numerical, like do you like Coke or Pepsi, would you rather have a dog or a cat, that's what we call categorical data. So there's two types, numerical and categorical. All right, moving on to talk more about samples. The goal of sampling is to obtain a representative sample because the statistic obtained from the sample is a good estimator of the corresponding population parameter. Some sampling methods can result in biased samples that may not be representative of the population and can produce statistics that lead to inaccurate conclusions about population parameters. So our goal is always to create an unbiased sample so that that data can actually help us make correct, informed decisions. Okay. So we have a whole bunch of different sampling methods, and we're going to talk about recognizing them and what they're called, pretty much. So a simple random sample is when every individual in the population has an equal chance of being selected. A self-selected sample is when individuals volunteer to be part of the sample. Self-selected samples tend to lead to bias because you have to think about who's volunteering for those samples. Okay, convenient sample. Individuals are selected based on how accessible they are. This can be a method of getting either a biased or an unbiased sample depending on the situation. Systematic sample. Members of the sample are chosen according to a rule such as every nth individual in the population. A stratified sample is when the population is divided into groups and individuals from each group are selected, typically through a random sample within each group. And then a cluster sample is the population is divided into groups and some of the groups are randomly selected. Okay, so now we're going to talk about in specific situations what kind of sample it is. So, for example, the officials of the National Football League want to know how the players feel about some proposed changes to NFL rules. They decided to ask a sample of 100 players. Okay, A says, the officials choose the first 100 players who volunteer their opinions. Self-selected, those are going to be biased because they are clearly volunteering because they have an alternate agenda. Okay, the officials randomly choose 3 or 4 players from each of the 32 teams in the NFL. This is what we call a stratified sample because the teams are already groups, so they've been divided into their groups, and then from each of those, we're randomly choosing some individuals. That's actually going to create a mostly unbiased sample. The officials have a computer randomly generate a list of 100 players from a database of all the NFL players. That's simple random, that's going to be unbiased. Simple random is usually the goal. Okay, administrators at your school want to know if students think that more vegetarian items should be added to the lunch menu. So they survey every 25th student who enters the cafeteria during lunch. That's systematic. It's generally unbiased, okay? But you do need to consider that maybe not everyone is eating lunch, and I don't know if there's like a certain kind of eater who eats lunch at the school. The administrator surveys the first 50 students who get in the lunch line to buy lunch. That's convenience. Probably unbiased because the 50 are probably still, but I mean, it could have some bias because you could have a group of friends who all eat the same kind of stuff. The administrator is making an alphabetical list of all the students. Then they randomly select 3 letters of the alphabet. All students with the first letter of the last name matching those letters are selected. That's what we call a cluster sample. So they've divided it into groups by alphabetical order, and then from that, they're taking whole groups. So that's our cluster. It's pretty much unbiased, okay? Moving on though, sample size. So the larger the sample size, the more accurate our data. That's the key, okay? Because if I only ask one person, then I'm only getting one opinion. If I ask 100 people, I'm getting 100 opinions. So we can calculate what we call a margin of error. That provides a limit on how much the responses of the sample would differ from the responses of the population. There's a formula for margin of error we use every time, and it's plus or minus 1 over the square root of n, where n is the sample size. So looking at a few examples on that, it says in a survey of 1,011 people, 52% that television is their main source of news. What's the margin of error for this survey? So that tells us our sample size is 1,011, margin of error, MOE. I write plus or minus 1 over the square root of n, or 1 over the square root of 1,011. I evaluate that, and I get approximately plus or minus 0.03 run. Remember, if we want to turn that into a percent, we move the decimal twice, and we say about 3.1% is the margin of error for this survey. Okay, so our sample said 52%. To find out how that would relate to the population, we just take that 52% and we add and subtract that margin of error. So 52% plus 3.1 and 52 minus 3.1 tells us that in an actual population, not just the survey, but in the entire, world of people, 48.9%, somewhere between 48.9 and 55.1% get their news from the television. Okay. In a survey of 1,202 people, 11% said they used the internet or email more than 10 hours per week. What is the margin of error for the survey? How many people would need to be surveyed to reduce the margin of error to plus or minus 2%? So I do 1 over the square root of that sample size. I get a margin of error of plus or minus 2.8%. If I want to change that to 2%, okay, now I'm just going to plug in the margin of error part of the formula, 0.02 equals 1 over the square root of n, and I'm going to solve for that. On the next problem, I actually go through more solving steps, so we'll go through that, how I'm going to solve that on the next one where I have more room, okay? A polling company conducts a poll for a U.S. presidential election. How many people did the company survey if the margin of error is plus or minus 5%? Remember, we do need to change that 5% to a decimal, so I move the decimal over twice, and that becomes plus or minus 0.05. The plus or minus on both sides kind of cancel. And so I say, okay, well, the opposite of dividing by the square root of n is multiplying by the square root of n. So I get 0.05 times the square root of n equals 1. I want to isolate the square root of n. So I divided by the 0.05. I went ahead and evaluated that. 1 divided by 0.05 gives me 20. And then I say, oh, the opposite of a square root is a square. So 20 squared gives me 400, which means that the company surveyed 400 to get that margin of error of 5%. Okay, so today the assignment's going to be Desmos and Delta Math. Hopefully it's pretty straightforward. If not, contact me with questions through email or Zoom.